This is the second lecture of the Computer Science 455 Software Engineering for Spring 2020 today, the 8th of April. Um, Last lecture, we talked about what is software engineering and what is the purpose of software engineering in the development of big complex software today. It is a very complex task because of the functionality and the structure and new paradigms in building large complex software today. And so we need software engineering to apply engineering techniques and procedures in the development of software. And we need tools and metrics as used in engineering to actually carry out the project. And as you remember, software engineering is um, uh, it's part of computer science and also project management. It is computer science because it involves the development of software, and it involves project management because it involves people. And you are interested in carrying out the production of software so it is under budget or on budget and delivered on time. We don't want a software project that would be over budget, um, and also you're late in your delivery. But you have noticed that in many large software projects that we see today. Well, the Windows operating system by Microsoft has been delayed so many times before, sometimes months or year, that the software hasn't been delivered. And also some big projects that is being undertaken is over budget. We don't want to be over the budget uh, because that's the resource that is given to the software company to finish the project. And if you are not able to estimate the budget and the time of the software, then you fail in the project management of the project. Okay, so uh, before I go to the topic of today, which is UML, today is introduction, although some of you have already used UML in your previous classes. Um, it is a requirement in the architecture and design for software. We need some kind of a blueprint of how we're going to build this software, especially if the software is huge, complex, and performs a lot of functions. To give you an idea of, of software, the study of software engineering, there is one program that I would refer to you, and this is software engineering at Carnegie Mellon University. They have a program called software engineering, and they have the master's and the PhD program for this course. So let me uh, let us visit the website at Carnegie Mellon University for Software Engineering Master's Program. If you remember, in my first lecture, um, I consider software engineering to be consisting of 5 major areas. Uh, the first one is the models of software engineering. The second one is the methods of development. Third one is architecture and design. The fourth is the artifacts study. And the fifth one is the management, project management. And here in the masters in software engineering, they have a program that is for those who are newly graduates like you. If you intend to continue your study, there is a master's in software engineering for recent graduates. And there are 2 of them, one for scalable system and the other for embedded systems. And duration of this course is for 16 months, so 1 year and almost 1.5 year. And this is an incentive for students to come and take the degree. Software engineers, according to Carnegie Mellon University, if you work at Amazon, Bloomberg, Cisco, Fitbit, Goldman Sachs, Google, and Microsoft, the median starting salary is 110,000. Okay, and if you are in embedded systems, and embedded systems has something to do with embedding software in machines or aircraft or any machinery that needs control. And the scalable system may include hardware as well. And our sensors, okay, our sensor systems, and that is quite a in-demand experience for software engineers. And the medium starting salary is 115,000, and they are employed by Aptiv, Clover Network, Fortinet, Goldman Sachs, Qualcomm, and Xilinx. These are kind of a hardware and software system. So let's look at the plan of study. And the plan of study are the courses that they need to take in a 4-semester school year. So this is 1 year. This is the second year. And on the last year, you have the I'm sorry. This is for 6 months, another 6 months, and another 6 months. And is that right? No. That is a semester is what is it? It's 15 weeks. Okay. So there are 4 semesters. 4 times 15 is 60 weeks. Okay. So that's how long it will take you to finish the program. And look at the courses that are involved in the study of masters in software engineering. You gotta have statistics, business and marketing, formal methods. Well, this is you are familiar that data structures and algorithms. There's agile method, quality assurance or testing, design, pattern and API design, requirements for information system. Then you have project management, software architecture, distributed system fundamentals. And so this is in relation to cloud computing and things that we do uh, on the internet. Quality management, DevOps is a new topic involving development and operations. So we forget that, that when we build the software, people are using it, and therefore we've got to include after we develop it uh, that it is operational to the organization and the people that actually use it. And that's important for the life cycle of the software to evolve into the use of the software in the company or system. In a scalable system, so these are courses that are involved in the building of scalable systems. And look here, they all need communications, important part of software engineering, that you're able to communicate. And there is internship on the third semester, and then there is the practicum and elective course on the last semester. Okay, so that is the program that is offered by Carnegie Mellon University for those recent graduates like you, if you want to continue your study in software engineering. Okay, so that gives you a what is the advanced study in this particular field. Okay, now um, the uh, the next part of our lesson today is the mobile app development team that we have here in our campus. Uh, the mobile app development team, and we have a website here in campus, and um, let me get you back. Um, okay, let me come over here. So here is the mobile app development site, which uh, some of you or all of you have access. And what it is a group of students that I lead in um, design and development of mobile applications in the campus. We were supported by the Vital Expanded Technology Initiative from 2013 to 2017. And during those first years of the MAD team, um, I have been um, sort of commissioned by the Information and Technology Services to actually develop mobile applications for the campus. And I use this class, software engineering, to actually carry out the initial prototyping or continuation of the project after it has been started in my class. Um, but later on, the ITS, which is um, the computing arm of the campus, relegated those campus mobile app to a specific group in ITS. But for a while, we have been developing mobile app for use in campus. Like I don't know if some of you have used CSUSB mobile. That was for a while the for a while it is being used by the students in obtaining information from the campus related to their courses, their financing, advising, and everything that is related to um, uh, their their academic program in campus. We also built a mobile app for the museum, and we call that the RAFMA, uh, RAFFMA, which is the uh, small museum, and they have Egyptian uh, artifacts, and we develop some kind of a virtual tour of the museum using using that mobile app. We also develop Tour CSUSB, which is a virtual tour of the campus, and uh, Google came to campus and they took a video of uh, the uh, video of buildings and streets in our campus. So it's it's like a visitor walking in the campus would see where you direct the mobile app. If you look to the left, you will see the building. If you look to the right, you see the open field. So it's like being in campus. It's just that it is virtual, and we give information about programs that are found in a particular building or in a particular spot in the campus. Um, there's another mobile app that we have built for the recreational center, and the recreational center, as you know, is a fitness center. So we give schedules and activities in the recreational center. So we support that. But then afterwards, during the last 2 years of the support from 2013 to 2017, the as I said, the ITS uh, removed that responsibility from the MAD team to a special group of um, people, developers in the campus that actually do the job. And so what is left is um, uh, we accept jobs from clients who have a need for mobile applications. So what you see here is a history of what we have done before, and there are mobile games. Most these two are mobile games, and Bubble Shot is a mobile game that was developed in 440 game design, and then continued in here in 455 into a mobile game. And here are the information about it. And it's a fun game, but it's actually a particular mobile game that we have published both in Google Play and in the Apple App Store. Okay, so very fun game for the students to do. Similarly for Slidewinder. Now, Case8 is a unique um, mobile app because of the need for um, social workers. If you remember, there were cases of social workers being held responsible for the death of a child under their surveillance. And this is a mobile app that allows a social worker to record the visit and reports uh, done by the social worker when he or she visits a house or or somewhere. And records also are kept for information about the case. Okay, as you can see, it is the website is no longer there. Actually, the mobile app has been the Case8 has been um, discontinued because of lack of funds. But we developed Case8 for the last maybe at least 3 years, and the purpose of the Case8 is a help for social workers to maintain reporting and timely advice to the um, um, to the clients, like abuse children in custody of people. Another important interesting project is the congenital heart disorder. And this congenital heart disorder was requested to us by Loma Linda University. And they had we have a PhD student in the School of Public Health that wants to build a mobile app for the caretakers of children with congenital heart disorder. And they requested a team from the software engineering class to actually carry out this particular mobile app. And this mobile app is actually help for information um, by the caregivers. And since the patient are usually young children, you usually have the parents or the grandparents taking care of the kid. But what happens is when the child uh, gets into an episode, and of course the caregivers, who are either parents or grandparents, panic in how to respond to the symptom being experienced by the child. And so it provides information, both text and video, to let the caregivers know what is happening and possibly to provide help on how to uh, uh, take care of this particular symptom. So it is a kind of a very nice mobile app to help congenital heart disorder kids. This particular mobile app um, was discontinued because of the transfer of the PhD student to another school. But we had fun while we are doing this. As I said, this was started in development in my software engineering class. Okay. All right. So um, another mobile app that we are developing is the Coyote Quest, and Coyote Quest is a information that uh, that allows students and visitors of the campus to find their way around the campus. And so you might probably have experienced it when you get a ticket for illegal parking, or you exceeded the time of your parking meter. You're given a ticket, and on the ticket it says you should go to the bursar office to uh, pay your fine. But of course, uh, the student, especially if he or she is new in campus, will scratch their head and say, where the heck is the bursar office?" Well, Coyote Quest will help you find that office by giving you a guide along the campus map of how to get there. Starting from where you are located, it will direct you to the different path in the campus grounds, and then inside the building, it will lead you uh, to the room where that office is located. So very helpful um, uh, um, mobile app, especially if you are looking for a office of a faculty member or a specific academic or um, uh, financial or educational office in campus. If you will notice, Coyote Quest is being continued in this class, and the purpose of the Coyote Quest version that we have here is to overlay on top of the campus map the water system or the electrical system of the campus for maintenance and troubleshooting. So good luck to the team who was assigned Coyote Quest. And here is the map and the of the campus, and we use here ArcGIS, which is a mapping a map that is developed here in our backyard. I don't know if you've heard of Esri. Esri is a company in Redlands that produces this software, and we use their software in um, drawing, um, putting on top of a passive map an information about that particular map. So it's not only for looking at the map, but also getting the information that you need. Okay, so that's um, the Coyote Quest. Uh, Optimal state is an interesting mobile app because this was requested by a faculty, Amy Wheeler, professor of kinesiology, and she has an idea about stress release of people or who are in the police or um, first aid, first responder, first aid, fireman that is in the field. So this particular mobile app um, actually monitors and track your state of mind and try to diminish your stress through exercise and through yoga or some other means to maintain what they call an optimal state. So this was started in the software engineering class maybe 2 years ago. I've lost track of where they are right now, but the last time I saw them, they were ready to actually launch the mobile app and um, start the business or selling of this mobile app. And so it's very exciting um, development if you see your mobile app being published or being used. SOS is a mobile app, much much older project, maybe 4 years now. And the SOS is a mobile app that notifies everyone of an emergency in a particular location, like a campus. Um, this was requested by a administrator in the Unified School District, Roland Heights School District, and she approached us with a mobile app that would inform police or first aid or medics about the situation occurring in a particular location of a campus. So let's say on the third floor of the building, let's say in Cajon High School, just across our campus, there's a shooting incident. And so the policy now of first responder is do not wait. As soon, do not wait for reinforcement or help. As soon as the police or SWAT team hits the campus, they go and try to um, confront the shooter to avoid more victims, and they should go in there and engage the shooter. Well, SOS will give them advance information about where is the emergency, and if there are many um, shooters, then they would know the number and how many are wounded. So it's an important information to SWAT teams and police to know who are they confronting and where. It also includes a chat session among those who witnessed the emergency to be able to exchange information among those who have witnessed the emergency, and the first responders will also see that, thus giving more information about the shooting. And we are still trying to launch this SOS, and who knows, maybe one day we'll get a call from the particular unified school district that they want this SOS. Okay, so um, you may not know what will happen to an app if there is interest. Okay, know and vote is a mobile app that was requested to us by uh, Rubal Kaba. Um, he is interested in this information about a political candidate, and through blogs and newspapers uh, and other sources, it would give information about a certain politician's stand on a certain political situation. So this will be very timely because of the upcoming election, if you're going to have them. Uh, and of course, uh, uh, hopefully this mobile app will give an insight on what is the stand of this political candidate. Um, this particular mobile app is being continued in this class. So there is a know and vote team that we have created, and they will continue this particular mobile app. So you'll be part of that software lifecycle where the know and vote hopefully will finish by the end of this quarter to be more functional than before. And another mobile app that we have developed for the Cal State system is the red folder. There was an issue that um, it should be the responsibility of staff and faculty and maybe students to be able to help another student who is probably experiencing stress. And this is some kind of a guide on what to do if you observe your classmate or your friend having difficulty in the school. And so rather than not doing anything, um, this mobile app will tell you to do something about your friend or acquaintance that there is help available in campus. So this mobile app is deployed. It is still running, and we developed it in software engineering class. And if you look at your at your screen in any laboratory or computer in campus, you will see this mobile app readily available in any computer. There's an icon that you can click, and it will give you campus resources and health assessments available in campus. Just letting you know of the resources. Okay. Now the team has been growing through the years because of so many um projects that we have undertaken. But the latest one that you see here are the students who were probably who were the last team that that were working in this particular group. Although we can continue this, but because of um, uh, the students are not anymore supported like being given stipend, um, we um, we kind of become an informal team, and anyone who is interested in joining that team can do so. But you see here a familiar picture of Chas. He was one of the MAD team, And through the years, well, of course, I lead the team, and Sunny Lin is an operations lead, the operating system lead in ITS. And here are the list of all the students who have been um, a intern in this particular group. As you can see, we go back as early as 2012. Eh, And I'm very proud of this group because it allows us um, to practice software engineering on real projects by actual clients in the class, and then continued on to completion after the class is over. So the um, the history of the mobile app. Okay. Now we continue to UML Unified Modeling Language. As you have used this graphics notation in previous courses, it is a family of graphical notations backed by a single meta model that help in describing and designing software systems, especially software systems that are built using the object-oriented paradigm. And this is the purpose of the mobile app or the modeling language, that we are able to express the design in terms um, of a notation. Um, this brief lecture is what I'm going to use in the discussion of UML diagram. We're going to use the book by Fowler. So please refer to your book, UML Distilled, a brief guide to the standard object modeling language. On all the diagrams I will be showing you in this lecture. Okay, so here is an example of the diagram called the use case. And this is a very important diagram in UML design because this specifies or describes what is the purpose or the functions of the software. The system is enclosed by a box, as you see here. And here are the users of the system. And you will notice that it could be a person, like a trading manager or the trader, or it could be a system, like an accounting system. And of course, salesperson is a person. But these are the users of the system. In UML, the use case diagram defines the functions of the software that you are developing. So we begin by specifying what are the functionality of the software. So for the trading manager, the function of the software is to set limits from this system that we are designing. And for the accounting system, it uses software to update accounts. For the trader, analyze the risk and make a price deal. And for the salesperson, capture the deal and also to make a price deal. Now, there is another function or use case that you see over here, which is value a deal. Now notice that this value a deal is not accessible by any of the user, but is used by the use case, or it's included in the analysis risk, um, the value deal. Same thing with the price deal. Now, this is only used when you want to represent a function, so a use of the system that includes another function, but is not available to the outside world. It is included in the function uh, analyze the risk and price the deal, to show some documentation that these two functions or use includes the value of a deal. Okay, so the very first step in the definition of a software is the use case diagram. As you see over here, we define who are the users of the system and what use the software will give to the user. So very nice simple diagram that could define those functions. Okay. Um, Here is another important diagram that you will need, and this is the um, um, the representation of all the hardware and software systems that will be needed by your software. So it's called a deployment diagram. Now, notice here that this depicts the hardware that will be used, um, and also the web server. It's depicted by um, a 2D box, and this big server here is also a hardware. We will call it application server. Now, what are the software that we need um, to develop in order to um, um, implement or develop the software? So inside the web server here, for instance, you need operating system, Apache, and other software that will be running in the web server. In the browser client, you need, of course, the browser. And in the this client here, it needs a file called execute. Inside the application server is another software that you will need called the Job GL exe, and here is the container that access the Oracle database. So what you have in here is a hardware, the hardware that you will need, depicted by this box here, and inside the box are all the software that you will need. This is a web server. The software residing in the web server are shown, and inside the browser client and the rich client, what software will be running in there. And the connectivity are defined as HTTP, or the local area network, or the internet. So, as I have said, the first important diagram that you need to to show in the software requirement specification is the use case. The use case diagram defines what is the use of the software to users, to people. And we depict them using an oval shape drawing. And inside the drawing is the function, which defines what is the use of this particular, what is the function that the software provides to a particular user. So the key word here is a verb or an action word that defines the use of the software. In the deployment diagram, you define the different hardware that you will use, like a server or a mobile device, a mobile that you will be using, or a laptop or a PC, and that is represented by a box. And inside the boxes are the software that will be running inside those hardware, whether they are platforms or they are programs that we need to write. They are included in this particular diagram. Now, here is another example of a use case diagram for the library. Now, notice here that we define the different users of the library, like the book borrower, the journal borrower, the librarian, and the browser, somebody who just wants to look at the what you can borrow from the library. So for the book borrower, what are the uses that the library system will provide to the book borrower? Where the things that the borrower would like to ask from the user is, how do I reserve a book? I want to reserve a book. I want to borrow a copy of the book. I want to return a copy of the book, and I want to extend the loan. So notice here, the keywords are verb or action words of what the software can do for the user. Here is another user called the journal browser. And the journal browser wants to borrow journal or return journal. So those are the functions that the system will provide to this user called journal borrower. The librarian wants to update the catalog. So the system called the library system will provide that usage to the librarian. And for the browser, of course, provide a browsing tool for the browser to look at what the library can offer. So very nice, simple way of depicting what is the purpose or what are the functions of the software you are designing. Now, this one is a little bit later into development, and this is what you call the sequence diagram. In UML, it is a very nice tool to depict what are the different subroutines or functions or modules that you are intending to use. And here is the example of that. All these boxes represent a component or an object that is part of the whole system that you are designing. Maybe it's an incomplete components, but for now, you want to analyze these four components or part of the software of how they operate in terms of how they perform the action of the different parts of the software. So here is this object called order entry window. So this is a window that provides to the user, and you type in what you need, and it sends a message to the next object called order. So prepare is a function that is called from this object called an order, and that function is received by the order, and the uh, the order is processed by the order. So notice here that there is an amount of time that is spent in processing that prepare order. See here? So at the end of this processing time, it will pass on the prepare with some information probably given in the previous message, to be passed on to another object called an order line. And it will be received and later has a function that needs to be returned called check. So check is a function in this object, and it returns a value whether the order has stock in it. So has stock, check is a function given to this object. It returns a value of yes or no. Then after some time later, it has a stock. If the stock, if this check returns a value that yes, it has a stock, then we need to remove that stock from the stock item. And if needed, we will need to reorder what we have removed from the stock. And after some time later, what happens is that this is a symbol that the object stock item is processing. If we need to reorder, it will do that, or some action that it needs to do. So it takes time. So it goes through here and then returns here. And if we need to reorder, then we send to another object called reorder item, needs reorder. And then here we return to the object that called me before. So order line actually send a message here if we have the stock, and of course here if we need to reorder, we'll do that. And over here, need to reorder, if it is we need to reorder that, then we have the object that does it. Returns, hey, I've got the item. And then later on, another has a stock. Do you have a new one? And the delivery item is been this is a function that the delivery has been done, and so on. So through this diagram, you will see the different objects in your UML diagram, how it functions, how the calls are made, what is returned, and what is the next event that's going to happen. So that is why it's called sequence diagram, and it's a good way to analyze the different objects of your design on how they operate, what messages are sent, and what acknowledgement are sent back. So very simple diagram, but it gives you a tool on how to watch the different messages that goes around the design of your model. Okay. Um of course, in class diagram, we have a very nice property of an abstract class where all other specific class can be derived from. Okay, so this is what you call inheritance uh, for a abstract class called Windows, and we have the Windows window, the X11 window, and the Mac window. So this symbol here means it is a subclass of the abstract window, and the text editor depend on the kind of window you have. Okay, so here in the object-oriented approach diagram, you can depict things like inheritance. And the nice thing about inheritance is that it inherits abstract uh, member function, and you define here the actual function for this particular object. Okay, here is a class diagram that usually you write, and here is an object or class called order. As you know, these are the um, data structures that you know, variables that you need, and these are the functions. So there is a class called order, there is a class called customer, uh, and there is an object, a inheritance here called corporate customer and personal customer. And here is a relation for a particular employee. The order communicates with order line, but since this line is unidirectional, order line cannot communicate with order. But order can communicate to order line. Communicate means sending a function and that or a particular parameter message, and the order line performs that request by executing its own function. And there is also a communication with an object called product. Now notice here that the, the class diagrams are incomplete. Some are just names. Some have um, the data structures but no function. Some have data structures and function, but the way you build your class diagram is via incrementation. So you don't need to finish the whole diagram at once, but have a what we call an iterative um, incremental paradigm that you continually improve your class diagram as you are developing your software. So that's one of the properties of the agile software development. You don't attempt to complete the step in your software lifecycle. It's better to start with something you know, and then uh, uh, and then continually improve your design and your implementation as you know better about the development. So you'll see here, this is an incomplete class diagram, but you have enough information here to move to the next step. Okay, class diagram. And here is a particular paradigm where each package diagram may consist of objects or classes inside this box. But the package diagram is a way to represent the high level design of your system. So if you cannot use class diagram to represent the different parts of your design, you can represent them as high level um, design. So inside this package contains a class diagram or even package diagram inside it. And this is the paradigm we use in computer science, which is divide and conquer. And so at the beginning, since I don't have enough information currently to define the classes, I can start with a high-level design that consists of uh, package diagram, which is um, a, um, um, a high-density package diagram where details will be done at some time later. But for now, I identify this as a big component of the system. Okay? And another sequence diagram, that's advanced features. We'll talk about that later on. But, and here is an example of the package diagram where you see here the detail of the domain package diagram is represented by two packages inside the domain. Okay, so you can start at a very high level design and then move to lower level design. And let's say this particular package orders will be detailed in class or object diagrams. Okay. All right. Now I want to move on uh, to the lab because of the different mobile app projects that we are going to do in this class. I already mentioned in the previous part of the lecture about the different objects or the different uh, mobile app projects we have done before, and some of them are being repeated here in this um, project. Okay, so let me do this. Okay, all right. This is in the mobile app development link, and we see the projects that will be undertaken by the Monday group. Okay? So the Monday group has this project called iBox Team. And what is the iBox mobile app? This allows a user to upload videos, pictures, and text to a server. Then you can view it, what you have uploaded. So the uploads are not public, but it appears that you can only view on your own upload. Okay, so this project is a project that was asked asked from us from Loma Linda University. Zoran Zivanovic is your contact person for this particular project, and he'll tell you more about the iBox. Okay, the Divining Rod project is a project by a client in the Philippines. He actually would like to help farmers in the field on how to locate water underground. He has a device that you stick to the ground, and it measures resistivity of the soil. And based on the data that you read, there is a algorithm that he used to actually convert the resistivity data into a 2D diagram of showing where the water is located. So Ben Alexander is, we started this project last spring, and he was involved in the project. So Ben will be a very good resource for this project, but your main client is Mars de Guzman. So he'll tell you more about the data he is collecting and how it could be used to uh, draw a 2D colored diagrams of where the water is located. Now, I told you about SOS. So this is a continuation, and the client wants an iOS version. Uh, we have an Android version, and your contact there is Rushav Picha. He is a graduate student in our program, and he worked with this uh, project, although software engineering undergrad class also work on this. And they were able to implement an Android version, but not yet an iOS version. So we will attempt to do that this quarter. Now, Bubblein iOS version, our client is Dr. Helena Ade, and this Bubblein is a substitute for Scantron. If you're familiar with Scantron, they are used for answering multiple choice questions. So we are replacing the Scantron with a mobile app with anti-cheating features. So Chas uh, is the um, is the main principal software engineer for this project. So we have been working on Bubbly maybe at least 3 years, and Chas is a very good resource person for this because um, he knows about this project. Uh, the know and vote, I also mentioned that earlier. Julian Rubalcaba is our client, and he wants this project done. We did one version last spring, so we're trying to continue this particular quarter. And of course, the quality assurance is the testing team that would approve or disapprove your prototype. So there will be an important team working with the rest of you to make sure that we have a running prototype when we give it to the client. For the Wednesday group, there is a bidder team, and bidder is also an application for farmers by Mars de Guzman. And usually farmers are cheated of the price of the rice. And the client wants to make sure that the farmer have all the data to determine if he is getting a fair price of the rice. You see, in the provinces, the buyer usually take advantage of the farmer and would cheat the farmer of a fair price of the rice. So he wants to help the farmers estimate what is a fair price. So the third party would not cheat on the value. Here we're going to have a Bubblein, but the Android version. So we have two versions at this point in time, one iOS and one Android. Chas again will be a good consultant, although our client is Dr. Helena Ade. Uh, we need to develop an Android version because the iOS and Android version combined is about 96% of the market. So we want to cover as many um, users as possible. Vextit is Michael Landon and Langston, and it's kind of a Twitter, but instead of text, you are kind of tweeting video. Actually, he wants to change the name, so he will get in touch with you and tell you about his ideas. So you will need to talk to him about the change of name, but most important, the function of this mobile app. We started Vextit maybe 2 years ago, so he wants to continue the project. Coyote Quest, as I've told you in the previous uh, slide, it's a water system of the campus. Overlay it over the campus map. Nick Perez is a student last spring. Now he works with S3. S3 hired him because of his experience in using the ArcGIS map. And Hector Ramirez is the director of um, the physical facilities, so he will help us um, draw the water system of the campus and overlay it on our campus map. And here is the breadth of the Coyote uh, mobile game. Daniel Mayer is your client. He was the project manager of this mobile game in my software. I mean, in my game design class last fall. So he'll be interested to see his um, um, his uh, Breath of Coyote um, port into I think this is a typo. It should be a iOS mobile game. And of course, the same thing we need here is the quality assurance team that would test the software developed by the 5 teams in the Wednesday group. Okay, so that's all I have for now, and continue organizing and uh, talk to each other. We have set up Slack so the teams can talk to each members through Slack and also among teams if needed, and with the TAs and myself. So we could start doing this. So the main thing that you should do is get a hold of your uh, client contact information. I'll give you that email address, and of course with your TA and consultant, they will help you get familiar with the with your mobile app project as quickly as possible. Okay, so that's it for now. Good luck on your uh, good luck on your project.